Hello, in this session, we will try to understand how we can bridge the unreachable of data by using RPA, and we will do that with the data integration with Fabric, SQL Server, Azure, and whatever. It can use the API systems and the connectors, but cannot reach data that might be saved in old applications or applications that are not reachable throughout something else rather than the user interface. My name is Fodios Majeras, and I'm a senior Power Platform developer. My expertise is in business application and robotic process automation. And what I'm doing in Microsoft community is to be a business application expert. And of course, I have a YouTube channel that you can, of course, check it out and see many videos about Power BI, Power Automate, Power Apps, and of course, PC tips. So let's see the agenda. We will start with a limited scenario about the application, the API limitations. We will also see what is the robotic process automation, the RPA, as we say. We will understand some of their benefits for our business and, of course, the technical benefits that we have. We will see what is the RPA for desktop and the RPA for cloud. And also we will go through a demo that will understand how RPA works and how we can take data to put it into Azure then and SQL Server and whatever we want them to be. So let's begin with a simple scenario, and let's say we work for Contoso sales company and we want to make a dashboard, but it's very complicated dashboard that our committee has requested it to have data from everywhere, from HRM systems, from ERP, CRM, and all type of data. But we also have some data in an old financial system of the company into a server, and or maybe we have to download data from a learning platform that is very old in our country. So let's see an example of an old bank system website. We have seen changes in the banks, but we can see these types of websites in old organizations or maybe some governments around the globe. And sometimes they don't have API system and they don't plan to have it in 1 or maybe 2 years. It's too much for us. We want this data to be now in 2 weeks. So what do we have to do? The team is very skeptical about it, and they have find out that Microsoft has launched some applications some of these years that are related to robotic process automation. They define the unreachable. What is unreachable? Unreachable means that there is no application system, application interface to download the data from a developer environment. There are no connections, and the only thing that we have is the user interface. So some examples, as I mentioned before, is to have a government portal, a legacy app that works inside our organization, or maybe what we see in our clients, they ask for learning certificates for their employees or their clients' employees, and we see that these learning platforms does provide digital certificates, but they don't have or plan to have an API system in order to give them to us. And they have it in internal servers for safety. So it's very difficult to have a connection. And also sometimes for government is they don't have cloud connected to the external cloud, and everything is internally. So there are some difficulties about this that we can use robotic process automation to solve these problems, and we see it through our clients. One thing what is to do a casting and have more and more and more employees to cover this position in these 2 weeks. But I think we have very limited time. We have to do it now. We have selection costs. We have a lot of selection time for this particular process. We also have the training cost and training limitation of the time. And of course, we'll have human errors about the repetitive process to take all this data from the systems and put it somewhere in order for the development team to take it and have it for the dashboard automation. And of course, it might be a boring work, so we will have maybe a high turnover after it. So I don't think that will work, and many employers will agree with me. So Microsoft has launched the Power Automate application. Is a business application that you use it as a low-code developer in order to make your life simpler. And if you're more advanced on it, you can do a lot of processes that are very interesting. So robot RPA, as we have mentioned before, is the robotic process automation, stands for robotic process automation. It's not a robot. It doesn't have arms or legs, or you can't see it in front of you. It's something on your computer. Let's say it's an automatic Windows assistant for workflows. It mimics the human interactions, types, clicks, and etc. It opens browser, it sends emails, and use your Outlook, your credential, your accounts to get in, or you can provide it with another account that is also for this robot. And of course, it works on the user interface of Windows, and no API is needed to execute these processes or take the data, only the user interface and the elements. There are a lot of benefits in accounting and finance. Accounting companies use it a lot, this, for their processes and to execute processes and set executive commands for transfers and money. And of course, there is operational efficiency behind it because it made the processes more quickly, more safe, does a repetitive work, and of course, it can goes and do different things simultaneously. So we reduce also the costs and the risks that are behind it, because there are a lot of costs about human and employees, and also cost about platforms, licenses, and other logistics that we need in order to have another solution for this. We reduce also the human errors, and RPA undertakes the boring and repetitive tasks that most of the employees don't like it to do it, and a lot of turnover has behind it this issue that something is boring. So it helps you and other employees to focus on creativity and what matters more. There are also general business impact, as we mentioned, which is the manual work that it undertakes, and it make it easier for us to have less manual work in a repetitive task and a boring situation with Excel files, with uploading of or downloading of data from these systems that don't have APIs. So it also prevents the human errors that happens sometimes, even in the expert people. And of course, we minimize the broken analytics that we mentioned before about our scenario in order to provide more accurate data from different sources. So if data cannot be moved, then insight can't exist, as we mentioned here. So we do want to have the possibility to take data from everywhere, and RPA bridges this last mile that we might not have in our organization. And of course, as we get deeper, let's explain. In the desktop flows, there are two different types. There are the attended and the unattended robots. And the attended one, as you can imagine from the title, is something that you can do it in your computer when you are in front of it and you can watch it. But and you have to be signing in the session of the computer with an account in order to happen. However, there are also some other robots which are the unattended robots, and you can say to them to sign in to be in a computer, in a virtual machine, your computer, with unattended access without you to be there. So you can have this robot at night to do work for you. And it's very, very productive. We also have, of course, technical benefits that we can highlight mostly. It's about the infrastructure and that it works on your Windows. You don't need to have a virtual machine, but you can build a virtual machine and the system. You don't have to have the application interface. You don't have you don't need to have an API. You do need to use the user interface elements and windows and browsers and systems, SAP, etc., in order to for your other world to interact and give them accesses like it is a human there, or to give it your credentials. It depends. So it can use your personal credential, it can use robotic process automation credential to get into it. And of course, you should do inside your organization safety checks in order to understand what it should happen and what is the level of confidentiality of your specific data. And there are two different types of flows application. For robotic process automation, for the Power Automate of the Microsoft, we have two different apps. It's the desktop flow that has the robotic process automation. It's this one. And also there is the cloud flow, which is this one, and works like an orchestrator for the desktop flows in order to help you to trigger. And also it has an application API system that you can connect it and take the data, and you can access Azure, Fabric, SQL Server, Dataverse, and all data systems that are in the cloud. So desktop flows does then reachable, and it connected with the cloud flow to bridge it with all the cloud. So if you use it at the same time, you have this bridge. And the desktop flows, as we mentioned, is the robotic process automation behind it, and uses the user interface and UI elements, and it happens locally into your computer or a virtual machine, and has interaction with it. But also we have the cloud flow as we mentioned, that has triggers, that works as an orchestrator, and has APIs on it. More specifically, in the cloud flows, we can see here I have two screenshots of the actions that are pre-made by Microsoft in order for you to use it very easily. And we didn't say that cloud flows are like the logic apps in the Azure, so it's very easy to understand it. And of course, we have Azure here, actions that we can see, and some actions from SQL Server. There are a lot of it to use it and do it things in our systems. We can make triggers and actions. There are differences between these two, but you can understand it. Trigger is when something happens in Azure, so it triggers the process and we can do the text automation. So we can have something in Azure, and when it happens, it can take also something from the desktop, trigger process in the desktop and take this data and upload it, like say. And also we have the actions. Actions are the actions that we put inside the flow. So triggers is the first one, and actions is what we have inside the flow. But in general, as you can see here by Microsoft, we should use the premium licenses, and you can check it out in the Microsoft licenses browser to see what are the costs, and you can also check it with your organization if they have specific packages and contracts with Microsoft. Next, we have the desktop application, as we mentioned, about the robotic process automation. But as you can see, I searched about Azure here, and we see the limitation that exists. There are indeed some actions for Azure in the desktop, but we have a lot of limitations. And also about SQL Server, it's not work for cloud. It's based in SQL Server connection, and maybe we do have a gateway or something to connect it with the cloud, but it's very limited. Is a little limited here because we can execute SQL statements. So it's also something useful for desktop applications. Also, we can see here the requirements that we need for robotic process automation. We should have Windows 10 or 11, and in general, in Windows 11, we have indeed activated the Power Automate desktop app, which is the pad. We name it pad from now on. Or we can download the pad or ask our company, our IT support from our company, to download and activate it for us. We should need a browser extension if we use the browser to run our application. But it's simple. We don't have to remember it because when we open the pad and we try to use the browser, it asks us to activate the extension in order to continue. So it's also very useful from Microsoft. We do need the premium license for connectivity and connections between the cloud flows and the desktop flows, as we mentioned before. And we have to register our machine to the cloud and connect our machine if we have a virtual machine and image that we can run our robotic process automation flows. And sometimes it can happen we might not found it our RPA flow in our cloud, but this happens because we forget to publish the desktop flow. When we make something, we have to publish it to our cloud in order to see it there. And I think it's time for our demo. Okay, perfect. And now we are in the second part of our session, and we will see the demo. We will watch this demo. And what we will do in this demo, I have prepared, and we'll see how we can make build a simple automation with RPA automation. And also what we do from this, we download the data, and we will see. And we want after that to get the data from desktop and publish. Of course, we publish the automation, and we will have the cloud flow, and we'll get this data, and we'll put it to the cloud in order to take it and put it into Azure or cloud connections, APIs, and etc. HTTPs. We can do it whatever we want if we take this data and put it into a table in the cloud. We will see how we trigger the automation, and we also see where are these connectors of Azure in the cloud. So let's go to Power Automate. Okay, we are going to our Windows, and we click Pod. We type Pod. It's this application right here, Power Automate. Enter. Okay, and I have prepared this demo. If you don't have this demo, you have to sign in into your account and click New and click New Flow. I will edit my demo to show what we have made here. It's a very simple application. It just downloads a file down and does nothing else. We could make something else like a repetitive task that is more easy to find it in organizations, to repetitively do it for multiple files and different users. So let's see what has happened here. It launches a new Microsoft Edge, so it's very easy. We have all the actions, and you can search for them very easily. And here is the main panel that we put all the actions one by one, and it happens in a sequence. So we put the launch new Microsoft Edge, and we have this simple URL, and we can enter on it. We might have a sign in and used our credentials, but we just enter on it, and we maximize it and save the browser into this variable in order to have the instance for our next user interface elements in the actions. We click in the search file. So here we just click search files, and then we populate the text .json. So in this stage, let's see what is the UI element. This is the UI element, and when you open it and you have to populate, you see I will do it from scratch. I want to populate where in the browser. So we have different here. We use the browser, so I take the browser. We use the instance that we had before from the variable browser, and then we have to indicate what is the user interface element. So I will add a user interface element, and I go here, I open the browser, and in the previous window it was this button, right? So anchor, I will click Control in my keyboard and click it, and it takes the instance. Here I can edit it. Why is this important? Because if you do it again and again and again, then you might have some names here that you want to change it, because it takes the code. This is safe, it's okay, but if you wanted another website or something was in the name of the website, it would be a problem for us. So we click save. I will click cancel because I have the populate, and we will see the next item is when we click the search file, I want as an employee to go here, click JSON, type JSON, sorry, sort by size in order to take the smaller, apply the filter, go down, take the name of the simplest in order to rename it when I download it, and why I want that? Because I want to save as, and save where? Save on my OneDrive. So if you go here, get details element, what I have to, as you see, I clicked the apply filter, I put the element here. I also send keys like go down, 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 down in the website, get details, which is the name, and we also have put the UI element that we wanted. And here, no, not here, just a moment. No, it's in the next one. So yeah, we clicked the anchor download, and also we have here these details. And you see here, if I wanted to use this for more accuracy, I have a problem. Because if you see here, it says the name of the file, and this should be dynamic. So what easily I have to do in this is click this, delete, and change the equal to and make it contains. Okay, so I change this, and I change this in order to take what it matters if I want to do it dynamic and not stops because I did it for one just thing. So we changed these elements to be dynamic. This is the key behind the robotic process automation. After that, we click Save As we saw, and I have put here a dynamic path. Why is this dynamic? Because if I do it repeatedly, I want to download multiple files. So what I have here is I have my path that I want, and then I have a variable. But where is the variable come from? From this get details of element. So it takes the names, get the details of the element that we see in the browser. It takes this element and put it into a variable, which is the file name variable. I can rename it, and I rename it. And I take it in a next step, a next action. So if we run it, we will take this file name and with the path and put it here with the name that we want it to be, and click save and save it in the right part. So let's demonstrate it. And after that, I have created here an output, but let's see it first as a run. So here my hands are here, and it's on my computer. Search JSON, small size, apply filter, go down, takes the JSON duplicate key, name, save as, click save as, write the name. Okay, we have a duplicate because I already did this process. So it download it, and it repeatedly do the same thing. So after that, yeah, we get an error because it stopped, because I already had it in my computer. So if I click it, yeah, I already have it here. So delete it, and again. To my hands are here. It uses my computer right now. We might have a VM and do other stuff and creative stuff this time, and not just watch a robot to do that. Or maybe if it does it at night, it is something different. We just leave it and we are with our families. So let's see. It ran successfully. Get file content using path. Okay, we might have to put a delay because it tries to get the file content. Uses this exactly path, and if I go here, we have this content, right? Yep. Okay. And after that, it set the variable, an output variable, which goes to the Cloudflow. It's the file content assigned to variable, find content, and takes the get file content by response, which is this variable here, and put it to the cloud. And we have to save it. And we will go to see what is the cloud. So if I open this instance here, this browser, I go to Power Automate. So you can go from Microsoft 365 or click here, make powerautomate.com. In order to go inside, you're going to my flows. We have cloud flows, desktop flows, and I will check the desktop flows. We can see our demo here, and we try to create an automated cloud or instant cloud flow. Instant happens manually when I want it to happen. I don't have a trigger right now from Azure or something else. Let's see from the old interface. This is the old interface, and we do it manually. New step, use desktop flows, run a flow build from desktop. And in order to see it here from our connections, because we have to create connections, I am going down, and we have to close this, and we have to click sorry, it's inside. We have to click publish, as we mentioned before, in order to see it in the list. We wait. Okay, right? Yeah, it's here. All right, so we go again back here, and we see our test is here. So can run the desktop flow as attended, of course, right now, and not unattended, right? But we have to have here the right connection. So if I click and save it, we can trigger it from here. And after that, we will get the data from the flow, and we can do with them whatever we want. We have a lot of actions here. I send an email or put it in Azure. So if we click here Azure, we see everything that is relevant to it. Run a prompt or create a job in Azure Automation in Logic Apps, and we can run SQL Server, but we need to do modification on Azure or the SQL Server in order to do to have a database and etc. So that was a demo, and we save it and run it, and we might have here, if I go back to my flows, we can create automated cloud flow, and when a pull request is closed, when a build completes, when a work item is assigned, to do things from Azure. When something happens is for automated cloud flow. Schedule cloud flow to start in a specific time and get our data every Monday or every day at night or during a session, after a session or something. And of course is the instant cloud flows is another, which is the manual triggering. So going back to our presentation, what we saw here was what is the robotic process automation? Robotic process automation is the process that optimizes, is the automation that optimizes our processes and do things for us in order to focus and do things that matter most in business. And we have two different things. We have the desktop apps which do the robotic process automation, the RPA, and we have the cloud which connects our data, which connects us, which connects our local machine with the cloud, with the globe. So we have these two things, the orchestrator and the RPA, to do our things. And before we close, I would like also to mention a quote that I like a lot about excellence is never an accident. It is always the result of high intention, sincere effort, and intelligent execution. So this reminds me to always to have intention and give effort in order to have excellence. But of course, we need the intelligence, and tools like this in Microsoft, in Power Automate, like Power Automate, gives us this intelligent automation capability. Thank you a lot, and I will, of course, welcome you later in my YouTube channels and the other blog channels. And thank you a lot, the Azure Innovators Hub that invited me in this session, and for their, of course, great hospitality every time. Thank you very much.
Hi everyone, welcome to the conference. Let me just get back to the first slide and we can actually get started. So firstly, welcome to the conference. So today we are actually going to discuss about a topic which is very near and dear to me. Like I have been working in this space for like almost 15 years now, and I've seen this space transform into what it is right now. And I'm actually really proud to be saying that I'm actually still very passionate about working in this space. So just to little about me on that note. So basically, like my name is Sai Kaushik Ponekanti, and I'm currently working as a team lead at Meta, essentially. So I'm working on the PyTorch data loading team. So I'm leading that. Essentially, like let's actually get back to the topic. So the primary topic that we wanted to talk today was how AI driven streaming analytics works and how we can build trustworthy real-time intelligence using the AI-driven streaming analytics pipelines. So one of the first things that we usually get a question, right? Like why is, I mean, let's talk about the whys, right? Before we actually go deep into how. So why is real-time intelligence a competitive edge? So essentially speaking, the sheer amount of data, like I've been reading somewhere that in literally 1 year we have actually processed data which is more than the data combined for all the previous years, which is not a normal amount, right? Like the sheer volume of the data itself is very huge, frankly speaking. So how do we get to process such high velocity data streams and act on them instantly becomes our competitive advantage. Let's take a couple of examples. Like as in, I just don't want to say that it becomes a competitive advantage without telling you guys why. So let's actually take a look into a couple of examples. So we can literally see these thing transform many areas, like for example IoT and sensors, user interactions, transactional systems, so on and so forth. Let's actually just take a slight preview into each of these systems. Let's take the example of IoT and sensors. So let's say you're running a manufacturing plant. Previously what used to happen was, like, let's say for example, in the manufacturing plant, let's say you have 10 or 15 presses or 10 or 15 machines which used to work, and frankly, like there used to be manpower behind all of these machines. So let's say if a machine is down, the production used to get slightly affected, because basically, like, of course, the machine is down, we have to find out why the machine is down, so on and so forth. And then again, the engineer has to first come and then fix it. It used to take like at least a month or so to get that up and running again. So ideally speaking, at any point of time, like let's say if you have 10 machines, the probability of one machine being down is very high, because of course, like let's say you fix one machine, the other machine goes down or whatever. So in the ideal world, the plant is not running at 100% efficiency no matter what happened. Now come to the real world, like basically like what is going on in the new world. Basically the manpower behind these machines has reduced by quite a lot. Mostly the machines are auto run. So how do these IoT and sensors work? Like for example, let's say we have sensors which actually monitor the health of the machine. Like for example, what temperature the machine is working at, like are all the parts working effectively, is the throughput of the machine proper, so on and so forth. So given all this data, if our streaming pipelines, which are real time, is able to find out that, hey, for whatever reason, let's say some of the valve is overheating, or one of the, like I don't know, one of the piston is overheating and it's not, let's say the oil level came down for whatever reason, because of which there is friction, there is overheating, so on and so forth. And essentially, as you can see, one thing leads to some other thing, like it's like the causation effect, right? Like so basically, let's say if the oil goes down, essentially, like, sorry, if the oil goes down, it eventually becomes the fact that, like, because of the friction, let's say your like heat goes up and the machine comes down. So you are able to find out that there is going to be a problem with the machine rather than the machine going down itself. So you are able to take preventative care. So the whole point of the real-time streaming system is to identify issues before they happen and try to find out what all things can be done. Like this is all pattern recognition, right? Like you try to find patterns which are abnormal, slightly abnormal ever. So like for example, here as you can see, the heat is going up. Try to find out why. You can actually stop the machine prior to any disaster, and actually like save lives as well. Like we have seen many instances where many lives were lost because of machine problems, so on and so forth, but here we are able to prevent literally everything. Now coming to the user interactions. So for example, let's say I'm on amazon.com, right? Like I have a 2-year-old daughter, so I keep buying some stuff for her, like as in like I buy some toys, whatever. So let's say that, okay, like I'm buying some, for whatever reason, some biscuits or some cookies for her, and essentially I get the notification that, like, okay, if previously it used to be the case that I buy something, that's it, I'm done. So for majority of the reasons, like for example, I'm very busy with my work, my personal life, it's not always the case that I'm able to be on top of the things that are needed to be bought. So let's say that if I'm buying something for my daughter, right, and it suddenly reminds me, hey, I see that you bought this particular cream or whatever about 2 months ago, so you must be running low. Why don't you actually try to take a look and buy that thing? So such sort of helpful recommendations is essentially what we are looking for. because see, the whole point of the technology is to make humans life easier, and as such they should be able to do such things. Now coming to the transactional systems, so this is one of my favorite use cases, and I've actually been a victim of this, so because of which I actually feel there is real value in this one. So now coming to the transactional systems. So think about this scenario, right? Like we have, I assume most of us have gone through this one, like where when I first came to the United States, like I don't know, like I was actually using my credit cards literally almost everywhere, because of which at some random point in time my credit card got hacked essentially. So I'm currently based in California, but somehow suddenly there was a particular transaction somewhere on the other side of the country. Again, like with previous systems, there was no real-time streaming analytics, so on and so forth, because of which, let's say, not let's say, like I actually had this scenario where someone bought a printer or something worth like $3,000 on the credit card. Of course, like lucky me that like I just called up the bank saying that like, hey, something happened, and frankly speaking, this is not me, as you can see, because of which like they were able to just refund me that money. Like as you can see, the transaction happened, but frankly, like I was lucky, but many couple of my friends were not as lucky. They had to pay that money, because of course, like even if it's not their issue, like frankly speaking, some mistake happened. So given this scenario, let's actually see how real-time streaming helps. Let's say that now the system knows that I'm in California, because most of my transactions are currently happening in California. It is almost quite impossible that I actually go to the other side of the country like within an hour or so, and then buy something there worth so much money. So basically, using real-time streaming, if the system is able to catch the fact that, hey, this user has never actually made a huge purchase in the last month or two, and almost all the purchases are in California, so there is literally no trend where he can actually go to the other side of the country and buy a huge purchase. So this data point where the hacker might have actually made, like trying to buy something which is abnormal, like as you can see, it is on the other side of the country and also a huge amount, and something which I would never buy, frankly. So such sort of data would definitely help stop the transaction even before it happened, like as in before the transaction actually posts. It should be able to say, like let's say when the hacker is actually trying to buy the printer itself, it should be able to say your transaction is refused because this is abnormal, frankly speaking. So thereby saving banks millions of dollars, and frankly, like it's no hassle to me, right? Like I don't even have to know such a thing. Like the bank has to just notify me that, hey, I saw that such a transaction happened, why don't you just change your card? So literally with so much less hassle, I don't need to call the bank, I don't need to tell them that my card got hacked, so on and so forth. They literally found out that all of this happened, and they are letting me know that. That's the beauty of it. So that is where real-time streaming shines. So now let's actually go to find out the impact of it. So literally the data is so huge right now that we are literally getting around 15 million events per second. That too, it like just take a moment to capture the size of it, right? Like 15 million events per second, frankly. And from ingestion to model inference, we are looking for a sub latency of around 30, less than 35 milliseconds, which is, which seemed to be impossible earlier, but like at least when I started my career, but now it's not so much. And which actually leads to 3x the model scoring, and frankly speaking, even in the faster inference space, because we are able to do faster inference, so on and so forth, because of which many organizations that have actually adopted real-time streaming are able to report consistently faster model inference, higher prediction accuracy, and dramatically reduce time to insight. So again, like as I said, the way that these things are used are multifold, like as in you can use it in any one of the things that you want, but the entire infrastructure which kind of enables this is the real-time streaming. Now let's actually understand the fundamental processing paradigms. So when I started off my career, we started off with batch processing. So again, coming back to my favorite example, which is basically like the my credit card transactions, right? So using batch processing, how it used to happen was there used to be periodic jobs, like as in hourly jobs, daily jobs, weekly jobs, so on and so forth. So let's say that credit card transactions, like as in I'm in California, a hacker made a transaction in somewhere on the other side of the country. So basically, like a batch pipeline runs, which actually for the best case scenario, let's assume that it is running on an hourly scenario. So the next hour, that I mean, okay, transaction posted at T0. So let's say the next hour compared to T0, we are able to see that transaction. We aggregate that. Then we find out that there has been something wrong. Then you post it to your bank statement. I as a customer have to call the bank saying that such a thing happened, and all of this hassle started. So this is the traditional batch processing. As you can see, there is a huge delay. It is nowhere close to true streaming. It is not at all real time in any sense. And basically, as it is like the one of the best batch processing pipelines are hours, like frankly, like there are daily batches, there are weekly batches. If your, let's say, if your infrastructure doesn't support hourly batches, I would not even know that such a transaction happened until the next day. So it literally gives it literally gives hacker the time to do so many more transactions. Like, let's say, think about it, like if he had spent like around $20,000 on my credit card, I mean, even the bank would have lost so much money, right? Even if it had to refund me. So then came the micro batching. Like, so slowly the streaming evolved into micro batching. So what is micro batching? We do small event group seconds delay. Like for example, we say, okay, like in this particular, let's say 60 seconds or 120 seconds. Again, it is minutes still, but basically like there are seconds as well. You can do seconds as well. It has balanced throughput and responsiveness. Ideally speaking, it is, I would say, near real time. It is not real time, but it is near real time. So where is it useful, right? Let's say you go to walmart.com or amazon.com, and essentially you see that like I landed on homepage, right? And then I, let's say, go to buy diapers or for whatever reason, and then I go to diapers page, and then I buy some cream, so on and so forth. And by the time I actually go to add to cart, it takes a couple of, I mean, it's not instantaneous, right? It takes, let's say 30 to 60 seconds or so on and so forth. So I'll be able to say, hey, this guy has been on Amazon for more than 60 seconds, so the probability of him buying something is more. So let's say we show some ads, so that way he is able to buy a little more. So that way personalizations help. But as you can see, it requires some amount of time to be spent on that product for you to actually generate that. Because for, let's say, I go to homepage, right? It is not instantaneous. Like, as in, from my analytics pipeline would never see that instantaneously, because of which there is a slight delay. I will, let's say, see that in, like, let's say 10 seconds or 15 seconds, and then post that. I'll be able to say like, hey, this guy has been to homepage of amazon.com 15 seconds ago. Let's actually wait another 15 seconds to see what he does, so on and so forth. But there is still that delay, like 15-second delay. But as you can see, compared to the batch processing, it's a huge jump. Compared from hourly, daily, and weekly, this is a huge jump. Now comes the true streaming. How do we do sub 5 millisecond latency? Like, literally think about it. We came from weeks, days, hours to seconds to milliseconds. So it is like per event processing. Like, as soon as you land on homepage of amazon.com, the server should be able to know that you are on homepage and essentially try to see what all personalizations can be done. So choosing the right paradigm is quite important. Like, frankly speaking, as you can see, this is purely the evolution. But if you can go back to how the companies do things, they always do hybrid approaches. Like, I wouldn't say every pipeline that you have, every analytics pipeline that you have needs to be true streaming. Based on your use cases, you can do batch processing. Based on your use cases, you can do micro batching, you can do true streaming, so on and so forth. For some of the very critical scenarios, you definitely need true streaming, which is actually possible right now. Now let's actually try to see what are the slight problems with this true streaming, right? So one huge problem that we have been seeing is temporal accuracy. So what does it really mean, right? So basically, imagine this, like, okay, let's say you went to amazon.com at T0, amazon.com, which is a homepage at T0, okay? And then you went to diapers cart page at T1, which is like 2 seconds later, essentially speaking. And for simplicity purposes, let's always assume the difference between any page interval is 2 seconds. Then you go to another cream page at T2, which is another 2 seconds later. But let's say when you send, so these are three separate events, right? So all of these three separate events, when let's say they go back to the server, Again, if you see Amazon servers, right, they are not just one server. There are multiple servers which are working in tandem. For all of them to work together, not all servers work at the greatest efficiency possible. So my backend analytics pipeline may see that, okay, like let's say Sai actually went to diapers page. So as you can see, the home page event hasn't yet come to the backend server, like as in the analytics pipeline. The event which came in was he went to the diaper page. Then let's say I got the event that I went to the home page. And then I get, let's say I got the event that I went to the add to cart page. The cream page, like the T2, the where I went to the creams to buy some creams, that event got lost. So as you can see, the order of the events is I went to the home page, then I went to the diapers page, then I went to some creams, then I went to add to cart. But the way that it got to the backend server, like the analytics pipeline, is I went to the diapers page, I went to the home page, I went to the add to cart page, and then I went to the creams page. So the order of the events which actually came to the backend server doesn't really make sense. Like how can we make personalization, right? Like you cannot directly go to diapers page and then go to home page. This does not make sense. Like because of which this is called the temporal accuracy. So basically the event time, like as in the event time when the customer really went into Amazon.com versus what happened during the processing, these two are two separate things. Like when data arrives in the system, there is a delay. This is almost always the case. Like no matter how much we try to optimize the systems, we cannot actually make some improvements in the network layer, because there are so many servers working in tandem that it is almost impossible to guarantee that this won't happen. So there are, like, how do we handle such things, right? So the brilliant minds who were working behind this actually came up with a couple of advanced frameworks. One of them is watermarking, one of them is event time windowing, so on and so forth. Again, like for the sake of this discussion, let's say I'll keep it simple. Like we'll try to just basically learn about what these mean, but I don't want to get into the complexities of this one, because they each come with their own complexities, because of which I don't want to get into that right now. But this mean understanding the true power of true streaming, I definitely want to give you a sense of what the problems are as well. So now, as I said, in this production environments, as I said again, significant share of data actually comes out of order. So how do we handle that? One of the things that I've mentioned was watermarking. So watermarking essentially says, how long do we wait for the late arriving data before finalizing computations? As in here, the order of events which we got in the backend analytics pipeline is out of order, right? So let's take that example. In the backend analytics pipeline, let's say we say 4 seconds, how long we to wait, right? Let's say we'll wait 4 seconds. What we say is, okay, as we got diapers page first, some event might be missing, right? Because this does not make sense. Like as into analytics pipeline, it does not know that home page will be coming before diapers page, so on and so forth. So because of which, what it will say is, I'll wait 4 seconds for the home page to arrive or any prior events to arrive. So within 4 seconds, if the home page comes in, that's well and good. Otherwise, we'll try to see what can. Otherwise, we will lose that particular analysis might be a little off. But we'll say before finalizing that analytics, we'll actually try to wait 4 seconds. So 4 seconds is a significant amount of time, frankly speaking. For the sake of this particular explanation, I took the example of 4 seconds. We usually don't wait that long because this is primarily true streaming. Like we want to keep the latency less than like 30 milliseconds or 20 milliseconds. So it's in the order of milliseconds that we usually wait. But essentially that's pretty good, like basically. Then comes stateful processing. Like for example, we need to maintain contextual state across events. So for example, we need to be able to say, even though we got 4 events out of order, all of these 4 events actually belong to one user, which is maintaining state. Like essentially you are saying that all of these events actually belong to one user. So make some sense out of it. And we need to be able to say that, like, home page comes first, then comes diapers page, then comes creams page, then comes the add to cart page. So that context is something which is really, really important. And then comes exactly once guarantees. So this is a very weird problem, I guess. Let's not get too much into this because it comes with its own. I mean, it's even hard to imagine sometimes. So think about this issue. If there is a chance of out of order, let's say one server which is processing, I don't know, add to cart event, right? It, let's say, times out, and it thinks that it did not send the add to cart event to the backend analytics pipeline, but it already did. It actually did send it. So what it does is, it, as it thinks it did not send it, it will resend the add to cart event. So the backend analytics pipeline will see two add to cart events, but here in reality the customer only did one add to cart. So such sort of duplicate events are also common, frankly speaking, because of course servers go down, there are network issues, there are acknowledgement issues, because of it this usually happens. So how do we actually ensure exactly one's guarantees? Like, we need to be able to do good analytics. Like, we should not be saying here that, like, many people, like, okay, I mean, we ran two add to cart events, or some people added two things to add to cart, as opposed to being only one thing added to add to cart. So such sort of things we need to be able to eliminate duplicate events, otherwise it corrupts. So now let's actually, like, these are the problems pertaining to real-time streaming, right? So let's actually try to look at a couple of platforms which enables true streaming. Is Apache Kafka, the high throughput data backbone. Like, literally, I mean, I think over the course of my career, literally almost every company that I've been to is built around Kafka. There is also a fun quote saying that, like, literally any system design or any question that you get in interview, there is a time to Kafka. Like, as in, how fast you get to use Kafka is decides how good of a candidate you are. It is literally that popular. And like, Kafka's distributed commit log delivers like exceptional durability, fault tolerance, throughput, and it's literally trusted by thousands of enterprises, as I said. So what usually happens is you get millions of writes per second. There is multi-broker replication, which with automatic leader election, configurable retention, because like model retraining requires that, and it also comes with its own rich ecosystem. There are Kafka streams, Kafka Connect. Like, it integrates with hundreds of sources and sinks. Like, literally, I mean, I've seen this used left and right, and in many crazy ways. Like, I've seen it used for logs, I have seen it used for events, e-commerce, finance, literally everything. And I think one of my favorite platforms, like, the throughput literally is super crazy. So this is one of the my favorite platforms. And next comes Apache Pulsar. This is second to none. Again, like, next generation streaming architecture. This is primarily purpose built for cloud native multi-tenant at global scale. Like, Apache Kafka is built for that. Like, everything has its own pros and cons, is what I would say. Pulsar actually comes with like traditional messaging systems, but for like the cloud native multi-tenant. So as it denotes multi-tenant, right? Like, it actually comes with separate compute and storage, scale processing and persistence independently, which, because of which you can actually cut down infrastructure costs. And then comes native multi-tenancy, which is like strong isolation across teams. Like, for example, I may be using Pulsar for financial systems, you may be using it for logs. We both actually can live on the same node because of the multi-tenancy. And built-in geo replication, like, for example, if I'm running an MNC which is actually spread across multiple countries or multiple continents, and I'm actually getting data from all of these countries or continents, I'll actually be able to do cross region data replication for globally distributed AI applications. This is really important for models, because, like, frankly speaking, models cannot have, like, let's say if one of my model is getting trained in India, it cannot keep on pulling data from reading from, let's say, United States or like any other place, because then you will pay a ton of money in network costs, which is not actually ideal. So to actually reduce that, built-in geo replication is one of the primary things which is required. And so again, like, there are many more. Like, for example, there are many more managed streaming services for accelerated AI deployment, like AWS Kinesis, Azure Event Hubs, and Google Dataflow. As you see, these are managed streaming services, like, as in they are married to a particular cloud provider. Like, AWS Kinesis comes with AWS, Event Hubs comes with Azure, and Dataflow comes with Google. So each of it has its own, they are very similar in architecture, but each of the products are actually, the USP is slightly different. Like, for example, Kinesis is auto scaling ingestion, like they are very very tightly knit into the AWS AI ML ecosystem. And when it comes to event hubs, it comes with Azure ML, Synapse Analytics, and enterprise identity management. And when it comes to data flow, it is Apache Beam execution. I mean, one of the ways that Google actually differentiated itself was the Apache Beam execution, again with Vertex AI and BigQuery, which is, of course, like BigQuery is something which is really popular as well. One of the primary things why usually people go for managed streaming services is they accelerate deployment, but they come with vendor lock-in. Like as in, you cannot, of course, logo, like, I mean, if I, let's say, if I'm trying to use AWS Kinesis, right? Like for the rest of the services, you cannot just try to use Google products or Azure products, because you will pay a ton of cost, like in just like using Azure and AWS or Google and AWS. Rather, you actually want to lock into that particular provider, which of course, because of the vendor lock-in, it comes with its own problems. And volume-based pricings, as I can say, that can escalate at enterprise scale. So we need to be able to think properly, I guess. Like Apache products like Apache Pulsar, Apache Kafka are more free run, like as in you can develop their own, like you can literally put them on your laptop as well. But they comes with their own problems, right? Like as in, managed streaming services are really really cool because you can accelerate deployment. Like as in, it takes literally minutes to actually spin up Azure Event Hubs or Google Data Flow. Like, I mean, I myself haven't worked with AWS Kinesis, but like I both worked with Google Data Flow and Event Hubs. So basically, like it literally takes minutes to spin it up. But if I, let's say, have to download Kafka and have to set it up, it's more like a week job. Like it's not that easy. Of course, like these are, yeah, basically that's the point of it. Now coming to what, like, okay, like assuming that, okay, we have gone through the entire things, now you have a decent understanding of what true streaming is. So let's actually see it in action. How do we stop the fraud before it happens, right? So again, like coming back to the credit card example. Previously we just touched upon the fact saying that, like, whenever there is a suspicious activity or a hacking transaction, ideally we should be able to stop it. What really happens behind the scenes? Let's actually take a look at it. So let's say that, okay, like, I mean, I've been living I've been living my life in a certain place, and frankly, like, most of my transaction are in a certain range and in that place. So the model has made a certain evaluation about me, saying that this particular user's profile is of this kind or follows this pattern. So because of which, whenever there is a suspicious activity of, like, let's say, very huge transaction happening thousands of miles away, essentially that transaction event is received. Then what happens is we extract the real-time features from that transactions. Like as in, we try to say, okay, what is the location where this transaction happened? What is the amount which is associated with this transaction? Let's say it also matters, like how soon or where this transaction happened, like literally which product place. Like, am I trying to buy a printer, am I trying to buy a random, I don't know, random product, so on and so forth. Then comes the model scoring. So model scoring tries to evaluate, like, based on my user profile, it will be able to say, does this transaction fit in with this person's user profile? Like as in, I'm okay, I'm trying to explain it in a way that you guys are able to understand. But basically, so we try to find out any outliers. Like as in, we try to see, based on this user's profile, is this transaction an outlier, or does this directly fit into the transaction? So let's say, like, the model scores that particular transaction. Based on that particular transaction scoring, we take automated decision saying that, hey, this particular decision is an outlier, because of which cut down the transaction at the core. Like as in, directly tell the user that this suspicious activity is something unusual, and frankly speaking, we don't want to make the transaction happen. As you can see now, let's take a look at the business impact. So let's say you are a bank, right? Let's say you are a bank running this true streaming. Let's take a look at the business impact. This is millisecond detection. Like literally, when the hacker actually clicked on the buy now button or whatever, all of this happened in milliseconds. This is like the wonderful part of it. As you can see, like, I'm smiling, like I'm really so passionate about the systems. Like fraudulent transactions flagged and blocked before completion. and there are very few false positives. Like any ML models are like dramatically outperform legacy rule based systems. Like previously there used to be rule based systems where we used to say, okay, like flag any issues which are outside something, so on and so forth. But these days ML models are like dramatically outperforming things. Like they are literally able to tell me things which I even I am a little doubtful about myself, but frankly that are they are so good. And then comes adaptive models. So continuously trade on current fraud patterns, right? Like as you can see, fraudsters and like hackers are like, I mean, they are not dumb people. They are like exceptionally smart people as well, and they come up with new and new schemes to beat the system. Like I mean, like literally, I mean, I've seen some really cool spamming systems as well. So but basically still, I mean, not to be, I'm not positive about them of course, but basically like the technology behind it is cool, because of which I'm just saying that out loud. But frankly speaking, of course, like they should not exist. And as such, your model should be able to adapt to such new patterns, and should be able to say that these are the new trends in spam and how do we block these trends. I mean, we should not be, as a human, we should not be telling the model this is the new trend which came in, find out how to fix it, but rather the model should itself be trained on that. So then coming to the personalizing experiences, now we have seen fraud systems. How do we personalize experiences through streaming intelligence, right? So as you can see, streaming platforms have taken over, like literally Netflix, Amazon, so on and so forth. Literally they are really good. Again, like streaming intelligence is not just like personalizing experience is not just limited to content. Like they are also like Amazon, Walmart, e-commerce, so on and so forth. Previously static personalization used to be the one, but with true streaming we are able to go to dynamic personalization. For example, let me go over this one. So a very simple use case. If you go to amazon.com, there is, and you are trying to, again, for lack of a better word, let's say you are trying to buy clothes. I mean, you have better websites for clothes, but let's say you are trying to buy clothes on amazon.com. So during summer, you try to buy a certain set of clothes. During winter, you try to buy a certain set of clothes. As you can see, there is a shift, like as in the trend changes. So basically, we need to be able to show the recommendations the right way. Like I cannot show you a recommendation for a sweater in summer, and I cannot show you like beach wear during winter. It does not make sense. So basically speaking, your model should be able to currently identify like literally what you're buying right now, and try to show you recommendations on what you will be interested in. Like for example, like most of my now Amazon feed is around buying products for my baby. Like at least even in the past year or so, most of the recommendations that I get are around like, let's say, how what creams are helpful for the baby, or essentially, or like for example, what toys are good for my 2-year old as she's growing up, so on and so forth. That is really cool, like because there are so many products out there that even I don't know, and frankly speaking I don't have the time to do that or search. This personalization is how actually systems help me by showing that there is this new product which might help your kid, why don't you take a look, right? That is really cool, frankly speaking. So this real-time click stream and browsing behavior is how the personalization is done. What you have purchased and long-term preference signals. As I said, contextual data like device, time, location, session state, so on and so forth. And then coming to real-time visibility for faster decision making. So streaming analytics powers a new generation of operational intelligence dashboards. So basically, previously based on batch processing systems and near real-time systems, there used to be historical reporting. Like as in, you used to see data which is 1 hour old, 1 week old, 1 day old, or even a couple of minutes old. But you are able to see data on your real-time streaming systems on your dashboards within milliseconds. Like for example, let's say you are monitoring some stocks, and you put up a huge dashboard saying, okay, let me monitor this stock. Based on how the graph moves, I'll be able to make some decisions. If an event happens which might affect that stock price, you would want to know it within a millisecond, right? You cannot say, okay, an event happened an hour ago and because of which the stock fell, and I don't actually know that event happened until like 1 hour later or even minutes later. I should be able to know like within milliseconds. That is the beauty of it. So which requires, of course, like continuous KPI monitoring, which is like live metrics which reflect current operational state. And like you have proactive anomaly detection, like for example, as I said, identify degradations, emerging issues before they escalate into incidences. Like as in with manufacturing, what we discussed earlier, like if a sensor is overheating, try to find out before a disaster happens. Like that is where we want to be. Automated and human response. Predefined conditions trigger automated actions. Like you can clearly say, if the sensor is overheating, let me shut down the machine before I can take a look. Before, because of course the whole point is to avert disasters. Like you don't want to be at a point where the disaster is going to, I mean, where the disasters are already happened. You want to be at a point where it might happen and you want to shut it down. And complex events somehow sometimes inform human decisions, right? Like basically you would want to personally take a look into that machine to see what is going on before you take a decision on if you want to switch it on again. So now, so building a trustworthy end-to-end streaming architecture, right? Like how do we go about it? So there is first a huge ingestion layer. Like you would want to have high throughput pipelines with back pressure, like as in high throughput pipelines like Apache Kafka. You would want to ingest data at a very fast rate. Like for example, let's say you are ingesting around like 10 million events per second, so on and so forth. Let's say your ingestion pipeline only reads 1 million events per second. Literally you are like, if there are 10 million events per second coming in, but you're only reading 1 million events per second, the rest 9 million events per second are waiting. Like you cannot, there will be huge delay in actually reading the data itself, which is a problem. Then comes a processing layer. Okay, you have ingested the data, how do you process it? There are low latency compute which we want with ML inference. Like we need to be able to process it at with low latency as well. Let's say I'm able to ingest 10 million events per second, but my processing layer itself takes 10 seconds, or let's say 30 seconds. It does not make sense, right? Why am I ingesting so much data so fast when the processing itself takes forever? And then comes real-time feature. Real-time features and incremental checkpointing, right? So real-time features are essentially more like, you need to be able to extract and infer features or generate features real time. Like you need to be able to do that real time. And then do incremental checkpointing. Incremental checkpointing as in, when your model is training, you read data in batches. Like as in, okay, you read the data which came until now, you process it, you store it somewhere, and then you read the data again, you train on it, you again build a checkpoint, you store it somewhere. That store it somewhere is what is called a checkpoint. So basically it is more like an incremental checkpointing thing. So the checkpoint is where you store the weights of the models, like how many, yeah, essentially the weights, the gradient, so on and so forth, because of which are required for the model training. Now when it comes to taking a look at it as a whole, right, like the reliability depends on all of these three layers to work in tandem. Like you cannot have one weak layer, or like let's say if you have an ingestion bottleneck, it will suffer the entire way. If you have a processing race condition or a processing throughput issue, it suffers again. Or inconsistent feature state, like if you, let's say some of the features are inconsistent. Really, all of these three pillars are actually important to have, make sure that your end-to-end streaming architecture is flawless. So pay attention to these three, basically that's what I meant to say. Now coming back to how do we ensure trust, compliance and reliability, because like governance must be designed in, like cannot be bolted on, frankly speaking. Like for example, if you are taking automated decisions at scale, like the entire integrity of the data pipeline becomes imperative. Like as in, it is really really important. Like for example, first thing happens is data lineage tracking, then you do quality validation, then you do model versioning, then comes drift monitoring, compliance audit, again feeds into the entire system. It keeps on going over and over and over. So data lineage tracking is more like end-to-end visibility. Like you have to be able to see what is going on with your model, like raw source to model output. And then AI asset governance, like what are the policies for model versioning, what are the feature store access, automated decision audit trails. You need to be able to audit your system at any point in time. Like this is how you build trust with the system, right? Like I cannot just throw the data, build a model and say that this model works. I need to be able to dive deep into any point of the model and try to understand, is it working properly. Data drift monitoring, like continuous detections of statistical distribution shifts. For example, as I said again, if your model just trained on summer data, it won't be able to design trends for the winter clothes. If as the trend shifts, it should be able to identify the trend and shift with it. Like how the data shifts is how the model should drift as well. Otherwise the model accuracy will go down. And then yeah, that's almost we are almost towards the end. Yeah. And then from reactive analytics is how we drive to the proactive AI driven enterprises. So first, when it comes to the AI driven streaming analytics, it's not an incremental upgrade, it's like a fundamental transformation. Like one of, as I said, for the proven foundations, there are Apache Kafka, Pulsar, Flink, cloud native services, and also like we discussed about managed streaming services. Then comes what is a trustworthiness, like as in you have governance, lineage, drift monitoring to ensure reliable, auditable AI decisions are taken at scale. Then comes continuous evolution. This is the important part too, like as in you need to be able to say your model is able to continuously evolve, continuously learn. Like I cannot just develop one model, use it for like months. I need to be able to develop that model or train that model every so often, like literally almost every day or literally every hour for that matter too. As you can see, the strategic imperative is very clear. You have to evaluate your current data structure against these all capabilities and try to build towards this streaming pipelines, AI driven streaming analytics architecture, where all of these real time decisions can actually create enterprise value. Now yeah, that's pretty much all I have to say. As you can see, like basically, and sorry about if I took too much time into explaining things. This is something which I keep talking more and more about. So but yeah, thank you, and I hope that you all have fun.
Hello, everyone, and welcome. I'm Naresh Sigamani. My perspective on today's topic is to build on 15 years in the SAP data trenches. I started my career as an SAP BW consultant while simultaneously working on SAP Enterprise HANA and HANA Sidecar implementation. Around 2016-17, I started seeing a shift on data platform architecture while extensively working on SAP BW and HANA. I realized both the tools cannot compete while the industry moves in a whole different direction in terms of data volume, advanced analytics, etc. While BW is the best in class in providing the business context, and HANA is best in class in providing the real time data from SAP ERP. When the transaction is posted in SAP ERP, you see that in a report in a second. But still, we were in the locked ecosystem when it comes to integrating non-SAP data. Over the last several years, I have led dozens of modernization and migration initiatives moving complex SAP workloads to cloud-native platforms. I have seen firsthand that I call as modernization trap or migration trap, where customers move to the cloud for low storage cost, scale, or AI, only to realize they have left their real-time edge behind. They end up needing fleet of engineers just to rebuild the business rules, and they spend significant amount of money. And also they spend significant amount of money on third-party tool just to ingest the data, often facing pipeline with data leakage and poor performance. Especially following SAP guidance regarding ODP extractors, many customers are left with low performing OData options as their only path forward. Today, we are moving past those BW, HANA Sidecar, third party cloud data platform integration. We are going to explore how the SAP and DataBricks integration finally bridged this gap, how the SAP DataBricks partnership bridges this gap, while finally unlocking the limitless scale of modern business AI and SAP Data Cloud. Let's dive in. For years, the industry have chased a dream, moving SAP data into modern cloud data platform to unlock AI. But as many of you have experienced, we hit a wall. I call this as the modernization paradox. We spend millions to modernize, only we realize we have created a semantic chasm, a place where data moves, but the business meaning, context dies along the way. We aren't just facing a technical hurdle, we are paying a data tax that stalls innovation. Let's look at the 4 friction points or pillars for the friction. First, the expertise gap. We have massive human capital problem. On one side, we have SAP architects who understands the deep, complex logic of ERP. On other side, we have cloud engineers who speaks Python and Spark. The reality is that mapping SAP internal logic into non-SAP environment isn't just a copy-paste job. It requires experience based on insight. When those two teams doesn't have a unified language, project don't just slow down, they fail. To move SAP workloads successfully to cloud data platform, we would need a team who understands both SAP and modern cloud data platform. The next one is integration and continuity. This is about semantic decay. Most third-party ETL tools act like a language shredder. They pull data out but strip away the hierarchies and the business context. We end up with dump tables on the lakehouse. If you have spent 80% of time rebuilding SAP logic in a cloud data platform, you haven't modernized, you are just moved your problem to more expensive location. Governance and security. SAP security is world class, we all know that, and granular. The moment you extract the data into the lake, you break the security chain. We need to have data protection and the guardrails over there. Last friction point is economics and strategy. Between the total cost of ownership of integration tool and the nightmare of licensing, the cost to innovate become a tax. We see organizations trapped between staying pure SAP and missing out on open source innovation. Strategic alignment means future proofing. We need an architecture that aligns with SAP clean core strategy without sacrificing the agility of the lakehouse. So, how do we cross this chasm? We stop moving data and we start federating context. To solve the paradox, we have to stop thinking that data is something to move and start thinking about it as something we federate. This is a blueprint of unified business AI in simplified version. It isn't just a connection, it is a strategic bridge. It starts on the left with SAP DataSphere. In this architecture, we don't treat SAP as a dump source to be drained. We treat it as a business data fabric. We consume data products from SAP application, consume CDS views with context, extractors. We keep the hierarchies, the languages, and the logic. This ensures that when the data scientists look for a revenue column in the cloud, it means exactly what it means to a user, to a business user in the CFO's ledger. On the right, we have DataBricks. This is our innovation engine. We bring SAP data into this open consumable based environment. We can finally blend it with the rest of the world. It could be a weather data, IoT stream, or a social trends. This is where generative AI and large scale ML comes into life. The magic is in the middle, the zero copy federation bridge powered by delta sharing. This is the end of data tags we saw a few minutes back about the integration. We are bypassing log-based replication or OData or ODP extractors entirely for SAP DataBricks or native DataBricks access. The data stays in the source. When a transaction happens in SAP and moves to DataSphere, the AI model see it instantly. Finally, the roof that holds it all together is unified governance. We are integrating SAP assets directly with DataBricks Unity Catalog. These are four traditional pillars that makes this federation possible. First, the semantic foundation. We consume data products from SAP DataSphere. We aren't just reading rows, we are reading the DNA of the business. Your AI doesn't have to guess what a cryptic table name means. It receives a pre-governed, clean dataset. Then the intelligence engine. DataBricks provides an open AI environment. Most importantly, it is polyglot environment. You can blend your SAP financial data with non-SAP data, IoT sensors, or competitive intelligence in all one place. Third, the zero copy bridge. This is the game changer. We use native federation to enable real-time queries. We are bypassing those slow third-party ETL tools as discussed in the past. And we eliminate the need of additional storage and the manual labor of building pipelines. Fourth, unified governance. Innovation without control is a liability. We utilize Unity Catalog to create security inheritance model, ensure that the trust built in SAP flows the data into AI engine. Let's talk about the evolution of retail intelligence. In retail, being right but being late is the same as being wrong. Most retailers today use periodic batch ETL or ELT to dump SAP data into a cloud data platform. The friction is clear. The data arrives late or get lost in ingestion leakage. By the time you blend SAP inventory with external weather data, the storm is already hit. You're trying to manage a supply chain through a rear view mirror. This architecture challenge the physics. We create federated reliance. We take the internal anchor, real-time inventory from SAP DataSphere and blend it instantly with the external signal in DataBricks. What does it mean to business? First, dynamic logistics. Trucks are routed based on storm paths versus job site priority, not just a fixed schedule. Second, proactive procurement. SAP triggers purchase orders for high demand materials 48 hours earlier than the competition. And third, unified governance. The financial controller has visibility into shipping cost and the inventory shrinkage across the entire flow. This is how you win the modern market. Now let's look at the heart of the business, the money. In industries like energy and utility, moving from metering to market is a high-stake game. Traditionally, this is a black box. Right now, non-technical finance users don't have direct access to raw interval data. They wait days of static IT reports. The result is massive settlement latency. If a CFO asks why leakage is spiking in a specific opco, it takes a week of manual forensic accounting to find the answer. The solution is the handshake between SAP data products and DataBricks Genie. We don't point AI at raw tables, we point it at governed data products via the zero copy bridge. Imagine a finance director asking Genie, show me the revenue impact of unbilled consumption for a northeast grid last week. Instead of days of SQL, you get an answer in a second because the AI is grounded in pre-governed logic. It can't hallucinate business rules. It uses the CFO's own definition to generate the trusted answer. This leads to faster revenue, recovery, and more accurate forecasting in SAP Analytics Cloud or any reporting solution. The biggest mistake I see organizations make is waiting for a massive SAP migration to finish before they start their AI journey. You don't have to wait. We advocate for the value first strategy. Phase 1, Phase 2, and Phase 3. Phase 1 is discovery. In 2 to 4 weeks, we identify high stake impact friction points. We don't boil the ocean, we map the existing data product ready to be unlocked today. Phase 2 is a zero copy pilot. In 6 to 8 weeks, we establish a bridge. We connect DataBricks with your SAP environment without moving data. We prove that the AI can understand SAP context and speak the language of your finance team. Phase 3 is intelligence scale. This is where you deploy a full power of Genie. We blend your core data with the outside world to move from reactive reporting to predictive action. This is how you outmaneuver the competition while they are still waiting for their migration to end. As we close, I want to leave you with the vision of the intelligence first enterprise. We are always from the era of IT was a bottleneck into an era where data is live, federated asset. First, business first, migration second. The multi-year migration is a foundational necessity, but it should not be an excuse for a stagnant innovation. Second, the context is king. Raw table are dumb, but data products are smart. By preserving business semantics, you ensure your AI is accurate and governed. Third, zero copy mandate. Moving data is the 20th century solution and 21st century problem. Federated access is the new standard of agility. If you stop paying the data tax, you start funding for future. My challenge is simple. Let's define your first high impact use case. The bridge is ready to build. Thank you for your time today. I will leave this QR up for a moment. Please feel free to scan to connect on LinkedIn. If you have any specific use case in your mind or just want to challenge the architecture we discussed, my door is always open. Let's build the future of unified intelligence together. Thank you so much.
Good morning or afternoon, everyone. This is Bharat Kalam, and I work as a Director, Data Architecture, Data Management for Onity Group. Today, I'll walk through a practical, research-based framework for building centralized data lakes that actually deliver performance, governance, and business value at enterprise scale. This is based on real-world challenges I've seen in large data environments, especially in financial services. So what is the challenge? We are at an inflection point. Data is growing exponentially, projected to reach 175 zettabytes globally. But the real issue isn't scale, it's readiness. Most organizations can store data, but they struggle to govern it, manage it, and extract value from it. And data lakes often become data swamps. So instead of enabling insights, they actually slow teams down. Traditional data warehouses were not designed for today's data diversity and scale. They struggle with rigid schemas, high storage costs, siloed ownership, and performance bottlenecks. At enterprise scale, these limitations become strategic problems, not just technical ones. To address this, we need a holistic approach, not just by tools. This framework is built on 4 pillars: architecture, governance, security, operational maturity. Each pillar reinforces the others. If one is missing, the system breaks down. So a high-performing data lake is not flat, it's layered. We suggest using a bronze, silver, gold model for the architecture, where bronze layer holds the raw data, no changes to it. The silver layer has cleansed and standardized data, and the gold layer, business study insights, is what it provides. This structure enables scalability, reusability, and faster analytics. So the foundation of all this is cloud object storage. The key advantage is separation of compute and storage that scale independently, support mixed workloads, enable massive concurrency. This removes the bottlenecks we see in traditional systems. But governance is where most data lakes fail. It's often treated as an afterthought, but by then we end up with data that is inconsistent, ownership that is unclear, and the trust is lost. And analysts spend more time finding data than using it. So how can we do better? Effective governance requires cross-functional alignment. Key components of it are clear data ownership, a centralized data catalog, enforcing data quality contracts, establishing a governance council. This is not just technology, it's people, process, and accountability. Another aspect of it is master data management, which ensures consistency across the organization. Without it, every report tells a different story, every project becomes a reconciliation. With it, you create a single source of truth and reliable analytics at scale. Security cannot be added later. It must be built in. At scale, reactive security leads to compliance risks, data exposure, high remediation costs. Security by design ensures safe scaling from day one. Coming to the security framework, we start with encryption at all layers, role-based and attribute-based access, audit logging, and anomaly detection. Data masking and classification are also part of it. The goal is simple: enable access, but control the risk. So let us go over how the implementation roadmap looks like. Understand that this isn't a one-time project, it's a phased journey. We move through foundation, which establishes storage, landing zone architecture, basic ingestion. Then to structure, implement the bronze, silver, gold layers that we talked about earlier. Then we move on to governance, cross-functional governance, data quality and MDM should be established. Then coming to security, end-to-end encryption, audit logging, and compliance assessments are all part of it. And finally, we scale it to other domains and implement self-service tools and metrics. Each phase delivers value while building toward maturity. Observability and telemetry. A data platform must be observable to be reliable. We track pipeline health, data quality, costs, performance. Without this, you're just flying blind. So coming to the key takeaways from all this, there are 4 things to remember. Layer your architecture early. Treat governance as architecture, not policy. Build security in from day one. Measure everything continuously. These are the foundations of a successful data lake. The real differentiator is not technology, it's execution. Organizations that succeed design intentionally, govern proactively, secure by design, and measure continuously. That's how you build data platforms people actually trust and use. Thank you. Feel free to reach out if you have any questions.